And people don't really think through when you get these unusual probabilities combining. I carry with me a set of dice, which I thought I'd get out if we have probability on the spinner wheel. These are called grime dice, and they have unusual numbers on them. And I appreciate you can't really see them, so I've got a shot up on the screen here. So the yellow one you can see there has got, it's got an 8, it's got some 3s. The green has got a 0. What's going on there, right? They've got crazy numbers on them. They're not 1 to 6. And the game you play is choose a dice. So you pick one color, I pick a different color. We roll them together. Highest number wins. Very straightforward, right? Except they're not all equally likely to win because they've got different numbers. But it's very hard to tell at a glance which is the best dice. I can now reveal to you that if you roll the red one versus the blue one, the red one will win more often than the blue. Not all the time, but more often. It's above 50%. The blue one wins more often than the green wins more often than the yellow wins more often than magenta, and so you get this fantastic ordering from the best dice, which is the red, down to the worst dice, which is the magenta. Or so you would think. If you play magenta versus red, the magenta wins more often than the red one. There's no best dice. If you remember this cycle and the person you're playing picks first, you can always pick a dice which has a higher probability of winning than they do. Same as the dice game, penny ante, right? As long as the other person picks first, you can always pick one that's better, which feels weird, but it's the same as rock, paper, scissors. It's like playing rock, paper, scissors, but you go first, and then I'll choose. There's no best option, but each one's better than another one, and each one loses to another one. Same deal on a higher scale. If you do play this, though, it gets a bit terrifying, because if people realize you're beating them, they will make you tell them the secret, and then you say, okay, I'll teach you the secret, and now we'll play 2 dice together. Why not? What they won't realize is if you play 2 dice simultaneously, it reverses the order. So you will pick first, and they will then deliberately pick the one that loses, because you've got 2. So that's the single dice game. That's the double dice game. If you're wondering what on earth is going on here, I've got a quick equation. There you go. Huh? It's also got more than one cycle, because there's another internal cycle of 5 in a different order. And if you double the dice, the internal cycle doesn't reverse. All it does is the top one becomes even. Right, so there's the double dice, there's the single dice, and so the outside one's flipping, but the inside one isn't. If you're wondering what's going on there's the new equation. All right, and I absolutely love them. If you want some details, the colors, I'm the come up with the colors. A friend of mine, a guy called James Grime, did the numbers. I did the colors. I'm helping. Because I said if they're these colors, then the length of the color goes up by 1 letter as you go around the outside cycle, which is why that's magenta, not purple. Purple has insufficient letters. And then James was like, well, if we make this one olive instead of green, the inner cycle is now alphabetical order. So you can now remember both cycles by looking at the colors. If you want all the stats, here are your advantages for any given pairing. The inner cycle is actually slightly stronger. The other one, here's all your numbers. Every single one is above 50%, apart from we couldn't quite get this one up to 50. It's just below.